Here we are back at the bench, and I seem to be experiencing a lot of failures at the moment all at the same time, and I'm having to improvise, which is one of the key features of being an engineer. Tell me if you agree in the comments below. So this is basically what I've got going on here, right? These are my LTO, industrial lithium-titanate cells. Now, I've got 6 of these for another project for a client. I didn't pay for these, luckily. These are well expensive. These are 60 amp hour LTO, and there's usually 5. You can see the holes there. I was like usually 5 cells, but I had 6 to try and match up 5 to give us a 12 volt pack. Now the problem is, when I came to, these have been in the cupboard for like years, literally, right? This one here is a good example. 0.2 volts when I measured it, so that's basically in the bin, right? Obviously I'll dispose of accordingly, but there was 6 and I'm down to 3. These 3 somehow managed to all be above 2 volts. Now the actual chemistry of LTO go from about 1.8 volt is the minimum you want to be driving them down to, 1.8, but the maximum voltage of the LTO is 2.8. and it usually hovers around the 2.2, 2.4 mark. It's got quite a flat curve, so they're lovely cells. They can go down to like minus 40 degrees centigrade and still give you juice. But more importantly, these things you can recharge like 30,000 times, especially these industrial ones. These are like for military submarines and stuff, right? So yeah, 30,000 recharges on these. But when I checked them out, obviously I've got these 3 good ones, so I'm thinking, well, all I can do is to try and make a pack out of 3 cells. So 3 times your 2.4, 3 times your 2.8 gives you 8.4 volt. But the problem I've got is I need to just top these off one by one first to 2.8 volts. But one of the failures I had was my main bench power supply, and I've been getting by for quite a while on this thing, which, you know, you've probably seen it before. They're like 5 amp or 10 amp or whatever they are, but they're quite good. You can get by with it as a backup. You'll also see here my TS100 soldering iron, my trusty soldering iron. You can see I've dismantled it. About 3 days ago, just went to do some soldering, had it all set up ready, just didn't light up. You probably see it in my last video. I hadn't had custom firmware with 007labs.com come up on the display. So that's just decided to totally give up the ghost. So I'm on a backup soldering iron, which is just nasty. There's no temperature control, nothing. So even that I'm having to run through an XT60 cable into my power supply so I can use that as some sort of regulation. But the other problem I've got is trying to charge these LTO cells, despite having a super capable RC charger. I've been in the whole drone business for many years as well back in the day, so I've got all sorts of chargers. This one is 1000 watt and does 10 cells. This is like, you know, my lab charger really. It does anything, but it doesn't do LTO. And so it won't go any lower than about 3.6 volt, which is lithium phosphate, which it does do. I even use this in lead acid mode to charge my off-grid battery bank if it gets low and there's no sun. So what I'm having to do to improvise, now my normal bench power supply that I used to have, which I haven't been able to afford to replace, would do everything. You know, I can set everything I want and set a constant voltage, constant current to charge these LTOs up to 2.8 volt. I can't use my charger because it sort of minimums out at about 3.6. So I've got this thing here that has just been sitting in my cupboard as well, that gets pulled out every now and again. This is a buck boost board, like 130 watt I think it claims. I've marked these trim pots here. You see this is the current, the middle one's the current, this one's the voltage. This is just the cutoff for minimum input power you can set. I just dial that right up, but I've set this to 2.8 volts and I've set the current to about 3.2 amps. And so what I've got rocking here is the main power supply is just feeding the boost buck board, and we've got 3.2 amp coming out of here. Because I don't have my main thing showing me exactly what amp and current and volts I'm actually got going on, I've got this little display here which is showing what actually we're measuring off this point here on the output. Without any load, that's 2.8 volts bang on. I'm having to go through this thing I mocked up ages ago one day and pulled this out, which is for measuring the current going in, which seems to have just turned itself off because I'm having to fiddle around with things like lithium polymer. I've got this lithium polymer battery. Let's see if I can get this plugged in. And you see here we've just got the current and the voltage that it's sensing through here. There's basically a shunt in here essentially, and this is like a $5 type thing, but it's actually pretty good at low current and low voltages. It's reasonably accurate, and you can see so far, I mean this is turned on and off, but so the counter resets, but this is putting about 13 amp hour so far into this pack. I think it was on about 2.24 when it started. This is the third and final cell to get up to about 2.8 volt. These have dropped down to about 2.7 by now, so I'll try and match these three up by topping them all off. So this is what I've got going on here, so I can measure. The reason I've got it set to what I've got it set to from the main bench supply, or the main backup bench supply, with the main backup's nasty soldering iron, so I can't do any fiddly soldering at the moment, which is unfortunate. But yeah, so this thing here going through again, I've got a nasty XT60 to XT60 female, which I make up various versions of that for convenience when I've got this situation where I've got it reversed because I'm, you know, measuring going in, not out. So I've got this on there so I can just make sure we're putting the right current in. And then I've got this little one on here, and again these are just things I've mocked up. This is just a little USB-C socket, and I've just rewired this myself basically, and I've got just a USB magnetic spinny thing with my two USBs. Obviously this one I'm powering, and I didn't have a third USB socket on my thing, so I've got this running on its own dedicated lithium polymer pack. And this is what keeps, this is a bit delicate, you see, because I've just bodged this together with a pin to pin into the LiPo. So, oh, nightmare, got it all going on. So this is showing 2.408, and again I've got my fluke, which is my, that's like my trusted lab voltage calibration when all else fails. So I'm going to bring this up to 2.8 volts, and then the plan is I'm going to be setting up these bus bars I had machined from pure copper. So these are nice. Obviously I had enough of these to do the 5-cell pack. I'm just going to be doing a 3-cell pack now. So I'm just figuring out how I'm going to do the balance cables. I'll do a Kelvin Y here, rather than tapping off here, which I use for like multimeter stuff. But for the actual balance cables, you want to do a Kelvin Y configuration, so you have a wire coming off here and a wire coming off here into a Y, and then you join it here, and then that's the balance lead for cell 1. Reason being, if you take it from here and there's high current passing through this bus bar, you'll actually get a completely different voltage here. So Y Kelvin coming off here, boom, and then we've got the same this end joined together, and then we'll have, if I can even find a 3-cell BMS for LTO, I'll let you know. But in the meantime, I'm just going to be improvising. There's that word again. So what I'm going to do is, when this one's finished charging, I'm going to switch this one so they're all basically parallel. So I'll put another bus bar across there, and I'll do the same at the top and basically link these 3 cells in parallel, so we'll get 2.8 volt coming out, or 2.7. I'll try and get these as close as possible, because the current that these things can deliver, if I try and connect them together and there's about 100 millivolt difference, it will spark like a bitch. So I'll get them as close as possible. We'll get all the negatives, all the positives connected together as one cell with 3 parallel. Then I'll do the same here, where I'll just top it up, all 3 of them, to match all the voltages and get them all stable, just by charging and topping them back off to 2.8 volt. When that's finished, I'll then switch the middle one around, so we've got our 3-cell series, which should give us about 8.4 volt roughly, 8.3 volt or so once it drops to about 2.7 volt per cell. So this will be in series then, so cell 1, 2, 3, this will be the negative, this will be the positive, and so that will be the one then pack which will be going inside a peli case as like a Cyberdeck on steroids. So then I'll be able to use my charger, because what I can then do is set this on lithium polymer mode, and by using lithium polymer mode I can actually reconfigure the voltage per cell in the settings of this. So I've whacked that down to 4.14 volts per cell, and I'm going to charge it as a 2S pack. So 4.14 then, not that we need a calculator for it, but we'll do it anyway. So 4.14 times your 2 gives you 8.28, which divided by 3 cells, yeah, is going to give us about 2.76 volts per cell, which is about comfortable for me. We don't need to top these things off to 2.8 volt every time. 2.7 is fine. So I'll be able to use this to charge as though it's a lithium polymer 2-cell pack to simulate what the actual voltage is of an LTO 3-cell pack, and then it's actually a reasonably okay voltage to play with on the lab then, where you've got, you know, we're going from about 8.4 topped out down to about 6 volt or so bottomed out at 2 volt per cell. That's actually pretty usable. We've got a nice 5 volt supply for things like Raspberry Pis. We can boost to 12 volt quite nicely, even with something like this. With the buck boost, 130 watt this can deliver, so we can have 12 volt outputs if we want, just using a boost. And of course, bucking down to 5 volt from 8.4, 6 volt is super efficient, so that'll be a real nice 5 volt supply. And of course these are super hardcore to the point where, you know, you can recharge these things 30,000, 40,000 times if you treat them well. So it'll just be an awesome Cyberdeck built into a peli case. But I've got to see if these things are still alive, because like I say, these other three went down to about 0.4 volt, 0.3 volt, and one of them was 0.21 volt, and there's just no way I'm getting them back alive, and I wouldn't trust them even if I could. But it's just interesting how I started with 6 of these things, and I just happened to think, oh, I really want to do something with these LTO industrial cells that I've got. And I went to check them, and the fact that these 3 were all 2.2, 2.3 volts, and they've sat there for about 4 years in the cupboard. One of the great things about lithium-titanate is the fact that the self-discharge is like less than 1% a month. So they literally last for, not forever, but as these 3 have shown, I don't know, maybe these 3 are super grade A cells, and they've never really had a full cycle on them. I lab tested them for the client when we were researching and developing with them, before we went in a different direction in the end. But obviously I ended up with them, and they've kind of sat there doing nothing since, so I'm trying to get things back in order. So I've got a new soldering iron ordered. It's going to be the TS101. This was the TS100 with my own custom firmware. I'm probably not going to bother with the new one when it turns up tinkering, but I've gone for the same TS, but the one up, the 101, it gives you the USB-C option to power it, whereas this one is just DC socket for power. And I've already got a good collection of TS type style tips. You know, I've probably got 6 or 7 different types of tips that I've collected over the years and things, so it sort of makes sense for me to remain in that ecosystem. The other thing as well is I came in the lab this morning, right, in my home office lab, and turned the lights on, and this went boom. Check it out. This is the LED driver for those, you know, like the LED panels. I've got the 60, I think, is it 60 centimeters by 60 centimeter ones on the ceiling. I've got 3 of them. in my studio. So this is one of the drivers for it, and this is I think now the third one over time that's blown. They seem to last about 3 years and go pop, and you can see this diac or whatever this is. It looks like it's blown down there, and yeah, there's also a lot of damage going on here. This resistor's just blown out, so it just went pop the minute I turned the light on. So now I'm having to improvise with the lighting I've got here because I'm one down, and I've ordered one on Amazon, and I actually paid £1.99 to have it on like same day delivery. So we'll see if that works out, because I had another video planned I got to do, which I can't do without that main light running. So that's the plan. I'm going to be trying to discharge as well this pack to measure the capacity, and I'm going to need to be measuring each cell individually to make sure none of them drops below, or none of them go wildly out as I'm discharging. Now this charger does do discharge, but I'm not sure if it's going to let me do it without the balance cable plugged in. This is the balance cable from 1 to 10 cells. I'm not sure if the discharge is going to work without the balance cable connected. I can do a charge without the balance because it's a separate menu. I can do fast charge, or I can do storage, and I can do discharge, look, down to 3 volt per cell, which at 2 cells would be 6 volt this would be looking for. But again, does that need to have the balance port connected? So, and then you've got the balance charge, look, where obviously it's not going to let you start charging without the balance port connected, so it can measure individually each of the cells. So I can't use that obviously because I'm pretending I've got a 2 cell pack when it's actually a 3 cell pack. So that will be the plan. But if I can't do the discharge on that, then I do have a digital load, again a backup sort of redundant thing, the same as like this is in my lab supply, would have done the same job this does as well, you see. And this I can just power with USB or power with a DC jack there, 12 volt, and this basically you plug into, like in this case, the battery pack, and this would simulate a load. So it would, you know, you can dial up and fine tune how much current you're simulating. So I can discharge the cells down and it will measure how many watt hours and how many amp hours it's drawn. And of course, to dissipate that current, it's just got a PC fan and heatsink here is how it works. So it's just a variable resistor essentially, right? So I can use that to discharge, and then I'll be able to measure the capacity overall of what I've discharged from it, so we get an idea of how much juice I've got rocking. And then I can obviously be making sure as it's discharging, as a series pack, that none of those cells are discharging wildly outside of the realm of the other 2. Now once I've got some circuits set up here, little strip board I've marked out where I want to hacksaw it. I've got a balance port ready, just a JST 2.54 mil spacing to fit the which is standard. I've also got some of these pigtails I keep a stock of, like 4, 5, 6, 7, 8 pin and stuff, with silicon, nice silicon already attached. And so what I'll be doing is to be soldering that on there with your 4 lines of cell 1, 2, 3, and the positive. And then I've got options then. So this will just act as the normal fly lead you'd have coming out your pack, which I can then plug in things like your balance, smart balancer. Again, this doesn't do LTO, but I'll put it on LiFePO 4 lithium phosphate, and then it will still show me the 3 cells, but it will just be showing them as like 2.7 volt or something. So I'll get the balance port rocking, and then I can also, the main wires coming off each cell will come into this strip board as well, and then I'll also have a socket which I can then put expansion things on there, like active balancers and stuff. So that's the idea. And I just felt like there's so many things that have gone wrong in the last week that have sort of failed. Like I say, and then this morning my main lights in the office going boom, And of course, like 2 days ago, my soldering iron just completely gave up the ghost, and I've got so much planned to do that I need to solder. So, and there's no way I trust this thing. It's like it's either way too hot and the solder's bubbling, or it's just only just melting the solder, and I'm fiddling around with that all the time, and the tip is just nasty. It's, yeah, I mean, it's kind of average, but there's no way I'm going to be doing the soldering I'm supposed to be doing with that. So I've got to wait until that arrives, even though I am compromising and improvising with this. So yeah, it just seems like this is a constant battle of always constantly having to find ways around things, and working around the limitations of the equipment you've got, or the resources, or the stock that you've got, and so on. And just to show that it can be done, we're ticking away here nicely. With, like I say, when we get to 2.8 volt, we'll be happy, and then we'll top the others off, and yeah, we should be rocking. So I'm going to leave that running, and I'll do another full video explaining more in detail what I've got rocking with these three, and I'll give you the results as well. I'll perhaps do a video showing how these three get on, and see if it is indeed a complete total loss of LTO cells, or whether we can make lemonade out of these 3 lemons we've got left. We might even be able to make champagne out of it. We'll have to we'll have to see. So make sure you keep subscribed. Loads coming up, especially with my AI inventory management system for my cabinets. I've started organizing some of these, so I've got a new idea with my AI inventory management system, which I'm going to be building with you, showing you every step of the way. I've got an entire rundown of the product plan for it, the same as I would present to a client. I'm going to present to you as though you were paying me, but no one is. So definitely don't miss that. It's going to be absolutely epic. So wish me luck with my little improvisations here, and I shall see you fine people in the next one.
.007 Labs. Beyond experimental.